Hello, everyone. We were in the middle of discussion with Boris. So I'm Aldis Karlovskis from the EIS group, and then greetings again from our knowledge partner Pact, who will award the most active attendees with free ebooks. It means comment, ask questions, send reactions, be active in all the ways how you can. And then there's a big opportunity to get free ebooks. And then for this session, we have Boris from Enterprise DB, who will tell us some new interesting things about how to use Kubernetes operator, as I understand. And we will learn a bit on how to make Postgres databases more secure or something like that. So, Boris, it's your stage. Teach us a little.
Thank you. Thank you, Uldis. And yeah, welcome to running Postgres security in cloud native environments with Kubernetes. My name is Borys Neselovskyi, and I am a senior sales engineer at EDB. Today, I am going to outline the strategy behind releasing cloud native PG, an open source operator for PostgreSQL that, in my view, will increase the adoption of Postgres in Kubernetes alongside applications. 90% of people believe that Kubernetes is ready for data workloads, but the lack of good operators is a challenge for a wider adoption. Postgres is no exception to this. Let's speak about agenda. I will present the journey EDB and Postgres journey. We'll explain cloud native PG, and we'll explain the capabilities of operator, and then I will make the live demo. EDB is the largest contributor to the open source PostgreSQL database, having contributed in the last 18 years to roughly 30% of its vast code base, including business critical areas like crash recovery, continuous backup, point-in-time recovery, physical replication, both asynchronous and synchronous, hot standby for read replicas, logical replication. We are also committed to its future by actively participating to the community and by stretching the technological boundaries of Postgres, and in a way, through the feedback we are able to collect at all phases of the customer experience journey, from consulting to 24/7 support. Our 1,400 customers, including a large portion of the Fortune 500, have put their trust in us. When it comes to Kubernetes, we are still a member of the CNCF and also the first Postgres company to become a Kubernetes certified service provider. We have also been a fond promoter and a platinum sponsor of the Data on Kubernetes community, whose goal is to foster the adoption of data workloads like databases in Kubernetes. When it comes to PostgreSQL, we all know it's a successful and innovative open source project, one of the most popular database management systems in the world, especially in virtualized and bare metal installations. However, I feel it's important to restate some of the mind-blowing capabilities that come out of the box with it. Many enterprise layer features that has been consistently added year after year, one major release after the other. My favorite list includes standard SQL, transaction DDL, continuous backup, point-in-time recovery, native streaming replication, declarative partitioning for horizontal table partitioning, extensibility with extensions like Postgres for geographical databases, parallel queries, JSON support for multi-modal hybrid databases, and so on. PostgreSQL implements the primary standby architecture with a single primary accepting writes and optional number of read-only replicas suitable for the read query scalability. Postgres has been repeatedly voted as the best database of the year by the dbengines.com website. Let's speak about Cloud Native PG or Postgres. You are here today to hear about our new open source launch, the Postgres Native PG operator for Postgres. Several years ago, EDB started to develop Kubernetes operator for Postgres, and since last week, we have declared the operator as open source. The sources can be freely obtained from GitHub, and we will be very happy if several contributors improve and further develop the product. We have applied to the CNCF sandbox with the goal to donate the project to the Cloud Native Community Foundation. As active member in both communities, our goal is to drive and foster collaboration between the Kubernetes and Postgres communities, certain that this will lead to improvements in these two foundational technologies and their ecosystem. I am thinking about the storage industry, for example, or the observability one, just to cite two. Our wish and hope is that Cloud Native PG will accelerate the rate of feedback loops in both directions, serving as a guide in this unexplored territory. And this is exciting. I will quickly go through some of the main public resources of Cloud Native PG that we should all get familiar with. This is the main website of the project. You can read the blog, you can go to the documentation, support, you can go to the GitHub. We have also the public roadmap for our operator, and you can see what is planning, for example, in Q3. And very important is GitHub. Yeah, you can just download the repository, you can play with it, and you can contribute to this project. We also are maintaining the images, the Postgres images from the version 10 till version 14. We will add support for the Postgres 15 version in the next quarter. And very important is the good documentation. Yeah, on the documentation side, you can just read how to install the operator, how to create a Postgres cluster, how to configure security, storage, monitoring, and every information is saved here on the documentation side. We adopted the convention over the configuration paradigm, which, by the way, we had already successfully implemented in Barman. This YAML file is sufficient to create a Postgres 14 free cluster, call it myappdb, made up of 3 instances, 1 primary and 2 standby servers, each with requested storage allocation of 10 gigabytes using the default storage class. Neat, isn't it? kubectl apply is the way in Kubernetes to apply changes to the cluster state. The first command is all it takes to install or upgrade the operator. The second one is to install a new cluster using the provided YAML file as definition. And this is the result. Yeah, we will create 3 pods and 3 pieces of storage in the Kubernetes. Our first database, first pod, myappdb1, is the master database. It's open to read and write workloads. And we also are creating the secrets, config maps for each cluster, pod disruption budgets, roles bindings, and so on. A very important thing is what we are created also the services, Kubernetes services. For example, service read-write is always pointing on the master, on the primary database. Yeah, read-only services can forward just read-only request to all replicas. PostgreSQL configuration must be managed via the parameters dictionary of the PostgreSQL map in the cluster specification. The operator has been designed to automatically manage reload and, if required, restart of the PostgreSQL instances following a change of their configuration parameters. By default, all replicas are configured in asynchronous streaming replication. However, you can configure streaming replication very easily using two parameters. Min sync replicas is the minimum number of instances required to be in synchronous replication. Max sync replicas is the target value for synchronous replication quorum. The command line interface for cloud-native Postgres is kubectl, the same we all use for Kubernetes. We have developed a plugin called CNPG for kubectl that you can use to perform operations such as switchover, TLS certificate generation, or display the status of the cluster, like in this example. In the Postgres cluster, we have only one database that can handle write transaction. This is the primary or master database. If the master database fails, Kubernetes detects the failure and together with operator initiates the failover process, with one of the replicas taking over the role of primary. The old master database is started as the new replica. The operator also provides a switchover, whereby a replicas takes over the role of the primary in a planned and controlled manner. This is often used when upgrading environments where the replicas are updated first, then one of the replicas takes over the master role, and then the master can also be patched. We can scale the read workloads by launching more replicants, and once the additional replicas are no longer needed, they can be terminated. And the failover, in case of failover, if our master database fails, the operator make failover to the next replica, in this case to DB2. The read-write service point to the new master. It means that the client don't need to change the connection string to access the master, because the clients checked, the clients have configured access via read-write service in Kubernetes, and service reconfigured the connection string to the new master. The old master will be started as the new replica, and read-only service will point on the new replica. In terms of storage management, we support persistent volume claims as well as storage classes for dynamic provisioning. As a result, our users have complete freedom of choice and use any of the supported storage in Kubernetes, both network and local. Remember, storage is the most critical component for PostgreSQL. You need to know how Kubernetes works and how Kubernetes manages storage on top of everything you already knew about Postgres and storage in VMs or bare metal scenarios. From our experience, The use of local storage is more suitable than shared storage for running databases in Kubernetes in terms of performance. Rolling upgrades. The only way to upgrade an application container is to replace it with an updated version of the image. As a result, a minor update of Postgres version means that the container image of PostgreSQL 14.0, for example, is replaced with the 14.1 one, without touching the persistent volume. Cloud-native Postgres is designed to handle this kind of operation, similar to Kubernetes deployments. It does it in a rolling upgrade fashion by first replacing all the Postgres replicas and then the old primary after switching over to a promoted and updated replica. Such switchover operation can be automated, it is default or manual. Rolling updates are also triggered then a change in PostgreSQL configuration requires a restart. Rolling updates are one of the main reasons why we didn't use replica sets or stateful sets in the first place. Security. As far as security is concerned, we adapted to the 4C security model of Kubernetes, performed at 4 layers: cloud, cluster, container, and code. We support security contexts and pod security policies. It's important to understand that thanks to immutable application containers, we don't need root privileges to run our container or to access volumes. On OpenShift, we go even further with support for restricted CSS, meaning that our containers can run using a random user ID. We support TLS connections as well as advanced and extended support for TLS certificates, including client authentication and integration with Cert Manager. Backup and recovery. We used all our 10 plus year experience with Barman in designing backup and recovery support. We currently support continuous physical backup on object store with an S3 or Azure compatible protocol, both in public and private clouds, for example, using MinIO. The object store where a cluster pushes backup data is called backup object store. We rely on Barman Cloud Vol Archive for vault shipping via archive command and Barman Cloud Backup for scheduled and on-demand base backups. Recovery is the way to bootstrap a new cluster by restoring from an existing object store either full or up to a point in time. We do support all options available in PostgreSQL for point-in-time recovery. Even in this case, we currently rely on Barman Cloud, especially Barman Cloud Restore to uncompress the base backup and Barman Cloud Vol Restore to pull Vol files on demand. Resources management. We do support resource management native capabilities of Kubernetes, such as CPU and memory requests and limits, pod affinity, pod anti-affinity, tolerations, and pod disruption budget. And we can show that in the future we will also support the different storage units for each table spaces, different storage units for Vol archive directories, and we will introduce the support for Postgres 15, and we will also introduce the logical replication. And now it's the time for the demo. Let's start with Postgres operator. I prepared some scripts. And in the first step, I will install our plugin. Yeah, you can remember with the plugin, we can administer the certificates and get the status of the cluster. I will install the plugin just with one command. I will download a plugin from GitHub and install it. It takes 2, 3, 5 seconds, and now the plugin is installed. The second step is to install the operator. Installing the operator is also only one command. Yeah, kubectl apply the operator. And we can see it takes about 2-3 seconds, and now we are able to create our Postgres environment. We can check if the operator is correctly installed, and we can see, yes, operator is installed, it's ready. And at the moment, we can create the cluster, Postgres cluster. I will show you the YAML file, what we needed to create the cluster. You can see in YAML file, I need to give the cluster name. In this example, cluster example, I will create a cluster with 3 instances, 1 master and 2 standby or replicas. I will create the cluster Postgres version 14.2 and with storage 1 gigabyte. Okay, let's create the cluster. And to create the cluster is just applying this file, cluster example. And now I will start the second window and go to my directory. Just say the status of creation of the cluster. I'm using the new plugin, yeah, Kubernetes operator plugin, and we can see that at the moment we have primary is created, and now the operator will create the second port for standby. The first standby is also created. The synchronization between master and standby is okay. And yeah, now we can see what we have in, I think, 20-30 seconds created our cluster, Postgres cluster. We can just check that the example 1 is our primary database, and example 2 and 3 are to standby. Okay, yeah, I will now just start CNP PG status cluster example to show you the whole output from the status command, and we can see that we are running on the Postgres 14.2 with 3 instances. The backup is now not configured, and the cluster is in health status. Yeah, everything is synchronized. Log sequence number is the same for all instances. Okay, let us now insert some data, yeah, to the Postgres. I will create one table test and insert 1000 rows to the table. I will just execute my SQL file and create the table. And now we can see what log sequence number is changed, but the cluster can synchronize master and all standbys, and now the old data is in sync. Yeah, we can just check restore, exactly. We can just select do select on our cluster, and we can see that the table is created, and the 1000 rows we can select the table. Yeah, it's okay. The next step is to take promote, to take switchover. Yeah, I can just change the roles. Yeah, I can manually say, okay, please make me my example2 as primary and example1 as standby database. Yeah, I will just say kubectl cnpg promote cluster to my cluster example2. And we can see here that the failover switchover is proceeded, and now in 2 seconds we will have our cluster example1 as standby database, and our old standby 2 is now primary. The operator can do it in very easy fashion. The next test is to test the failover. Yeah, we can say, okay, if our primary port fails, what happened in this case? Yeah, for this one, I created the test failover test. You can see I will just delete the port cluster example2, what is meaning our primary database. And last, let us check what's happened. We can see that example1 took the role of primary, and the operator started the new image for example2 and make it synchronous, the new standby. Yeah, everything is automatically works automatically, and Kubernetes is monitoring the status of pod, can restart the pod, and operator know what is to do from the Postgres point of view. Okay, let us take the next step, and next step is upgrade. Let me show you one file. I created the new YAML file, and you can see that our old file have the Postgres version 14.2, and my new file have the version 14.3. It means I will make the minor upgrade on the new Postgres version. Additional, I will add the backup section. I will add my S3 destination. I created already my min.io backup server. I need to provide destination path, endpoint, point URL, my credential, and now I can just apply the new YAML file, and let us see what will be happen. Yeah, I can show you the min.io console. I have min.io without any directories now, and now I will just create the backup. To upgrade my cluster. I will just apply my new YAML file with upgrade to the version 14.3 of Postgres, and to add my backup description. Let's do it. The upgrade is is produced in rolling upgrade fashion. At first will be upgraded the standbys, then it will be proceeded the switch over to the next upgraded standby, and then at last step will be upgraded the old primary and will made as standby. We can see now the primary is example2, yeah, and the example1, our old primary will be replaced with the new image of Postgres. I hope it will be working. Let's wait. Yes. Now we have already upgraded our cluster, in rolling upgrade method, and you can see now if I will execute my command, we can see here what Postgres version is changed to 14.3. In this easy way, we can just upgrade our cluster. And interesting thing is we added the backup description to our cluster, and we can see that now we have the backup. It means that I have in my min.io already backup from wall files created. Yeah, we can just browse. We can see this is backup cluster example cluster walls, and my wall files are already backed up to the S3 storage. As the next, I will do the backup of my cluster, initial backup. You can take backup, one-time backup. You need, sorry, it's not VI. Just we need to create one backup file with backup name. In this file, backup test with a cluster name to be backed up, and you can run backup one-time backup, or you can schedule backup. Yeah, you need for scheduling of backup some rows more in this file. And now I will run my backup. We have the command to check the backup describe, and you can see that now backup is started. And I will just try it again, and we will see that backup is now completed. What means that in my min.io directory, I have now the directory base, with backup of my Postgres cluster. As we can see, the backup running backup is very, very easy with operator. We have created with Barman Cloud tool utility. We are able to make backup with 2-3 lines of code. And also is very easy to make the restore. The restore of Postgres cluster with Kubernetes means that we will create always the new cluster. We cannot restore in place. Yeah, we will create the new Kubernetes cluster for Postgres, and then take backup and make restore and recovery to this new cluster. For this, I will now create the next YAML file. Everything is declarative. We need for each operation the YAML files. And the YAML file for restore says the name of the new cluster, in this case, cluster restore. We need to provide the Postgres version image, because you can restore only the Postgres version what you have in backup. Yeah, we have in backup 14.3, and we need to restore the same version. And we need just say what is the backup name, backup test. And now we can just run restore and check what has happened. The cluster, new cluster will be created, and it will be recovery will be started. And after that, this pod will just now I think we are ready. Our new cluster is created. We have the cluster restore, and to check if the data, if our table test with 1000 rows is available in the cluster, we can just select from cluster, connect us to cluster restore and select the table. And we can see that the table is already restored, and on this very easy, with this very easy way, we can just create backup, restore cluster, and make your life very easy by maintenance of Postgres on Kubernetes. Okay, yeah, let us go back to the presentation. I have some slides more. The first one, this demo, you can do it by yourself. My colleague Sergio Romero created the demo for KubeCon, and you can just download the demo from GitHub. The slides can be downloaded, and you can just download the scripts and create the demo and test our operator. And as conclusion, with cloud native PostgreSQL, you can get the best of the two worlds. Use the extensive set of features that the community PostgreSQL provides on the most advanced open source container orchestrator, Kubernetes. The other side of the coin is that you need knowledge on both technologies. Don't even attempt at using PostgreSQL on Kubernetes without knowing Kubernetes, and vice versa. As the last remark, the key aspect to understand is that with Kubernetes, all applications coexist in the same distributed system. When referring to applications, we include also databases, a special kind of applications of workloads that require more attention on storage. Yeah, at this point, I think I am ready. Thank you very much. And I'm able now to answer your questions.
Yeah, for now, we don't have any questions in the chat. Let's give it some time. Please, waiting for your questions. There must be some. In the meantime, Borys, maybe there's something crossing your mind, what you want to add? What can we expect next from Enterprise DB for Postgres?
Yeah, I think the Enterprise DB is working together, very close to working together with communities, with Postgres community, and also now with Cloud Native Community Foundation, with Kubernetes communities, data on Kubernetes, and we can expect the new features, for Postgres and Kubernetes. For example, I expect integration with, for example, Active Directory on the Kubernetes, with creating some other capabilities to session management, pool management for Postgres. We are developed now. It's unfortunately not free. Our bidirectional replication operator. It means we will have multi-master solution on Kubernetes, and you can have the Kubernetes cluster across the different regions, for example. Several new things are now in the roadmap, in the open source roadmap, and also we have some features in the enterprise area. And I think with the new Postgres version 15, we will become the new good features of Postgres. It will make Postgres more performant, more with several good new features, and I am very excited to working with Postgres working with Kubernetes community, and I'm looking forward for the new features and new exciting discussions.
Yeah, very exciting indeed. Just so I got this right, was everything what you demoed available in a community edition?
My demo.
Yeah.
Yeah, exactly. You can just exactly. This demo is on the GitHub. Yeah, it's community edition. It's open. It's free. You can just go to GitHub, download all scripts. What we have, the demo is based on the D3K. Yeah, you need this rancher. This is a little rancher Kubernetes environment. Every can download it and run it. And yeah, demo included all scripts. Yeah, you can just play with Kubernetes, with operate, and everything is for free.
Okay, amazing. That's great. I don't see any new questions coming in. I guess that's it for today. Thank you for your presentation. Very interesting and awaiting the next features. Thank you, Boris.
Thank you very much. Have a nice day and good conference.
Thank you. Bye bye.
Bye.